I have a new toy. This is something I have been wanting for a long time, and I just picked it up on Facebook Marketplace yesterday. If you're not familiar, this is called an optical comparator, or sometimes a profile projector. As you can see, it takes our little part down there and makes it big up here. I've been needing one of these things for a long time, and so when I saw one on Facebook Marketplace that seemed like it was in great shape, I went and got it pretty much immediately. It was about a 2.5 hour drive. My wife and kids went with me, which was a lot of fun. And we met a wonderful man named Dennis who sold it to me. Sometimes on Facebook Marketplace, you don't know what you're gonna get. Most of the time that comes back to bite you. This time it was the opposite. This thing is beautiful, it's pristine. I have no idea what brand it is. I assume it's a relatively cheap import, but it is in great shape. The only problem with it at the moment is this indicator right here does not have batteries. I have tested both this indicator and this indicator with the same set of batteries by swapping the batteries between them. This one right here is a Starrett. This one is a CDI. I'm not familiar with CDI, but obviously we know Starrett. This one seems to measure in 5/10 increments, and I believe this one measures in tenths increments. So I'm kind of tempted to swap these and have the finer resolution down here. The movement axes on this thing kind of reminded me of my old Sherline lathe. And just like the old Sherline lathe, it had gibs that needed to be adjusted. When I first got it, the Y-axis, which is up and down, would slowly droop. But literally 3 minutes with an Allen wrench let me adjust that. So now it's nice and tight, but moves freely in all three axes. So this knob here moves the part up and down on the screen. This knob here moves the part left and right on the screen. And then this knob here changes the focus on the part. Just like my little Sherline lathe, it has a little tiny aluminum T-slot table here. Again, that's using dovetail ways with a tapered gib. For linear measurement, it just uses these little drop indicators. It has this tip here that hits this movable pylon, so you get your part to approximately the right place, and then you can move the pylon and zero the indicator before moving the machine to get your measurement. In both axes, it has just 1 inch of travel, which means the biggest feature I can measure is about 1 inch. I don't think this is gonna show up on camera ever, even in 4K, but there are tiny tick marks on this. They appear to be in increments of 10,000ths of an inch, and I can also use those as a ruler to measure parts in addition to moving the part around with the indicators. There's also a tiny crosshair right at the center, and then a pattern of concentric circles going around that to help you get centered on like a hole position. The whole top half of the grid that you can't see is kind of like a protractor, and you can rotate the whole screen to help you measure different angles. The bottom half is just a normal rectilinear grid. At the top here, there's some markings. They go from 60 to 0 and then back to 60 again. Initially, I thought those were degrees, and then I thought about it a little bit. And the 60-degree mark is really maybe at like 15 degrees. And so I'm not 100% sure what units those are. Maybe it's part of like a vernier scale on the degrees, or maybe it's something like arc seconds. I don't know. I'll have to do some research and ask people who are smarter than me. Speaking of asking people who are smarter than me, if any of you guys recognize this unit or this model, if you know the manufacturer, please leave it in a comment. I have no information and there are no markings on this thing. There's nothing. One of the indicators is Starrett, one of the other ones is CDI, so that doesn't even help. I assume one of those was replaced at one point, probably the Starrett one. Another very smart person who I've been talking to is Stefan Grosch. You know, the German YouTuber guy whose name is really hard to spell and even harder to pronounce. I've been just peppering him with questions about this thing because I have never had one of these before. I have used one like twice, but there was a friend there who really did the work and I just, turned the knobs as he told me what to do. So there's gonna be a little bit of a learning curve. The other thing there's going to be is a shop project curve. And I think that's what we're gonna do today. If you've ever done any machining, like at a professional level, at a hobby level, at any level, you would know that work holding is 95% of the battle. Now, obviously with this thing, there are no cutting forces. It's all just about positioning the part in a manner that is convenient and accurate. Honestly, just sticking the part on a 1, 2, 3 block is already not a half bad solution, but we can do better. There's a lot of like time tested and intelligent things that I could do for part holding on this machine. For example, I already have this little fixture plate. I could put a rail across the back of this table and make some various like toolmaker style blocks to hold my parts and position them differently. That would be the smart thing to do. But this modular organizational system here is one of my true loves. I love how easy this is to organize things and to move things around and to make custom little bins for custom little things. Like basically all of my stuff is organized with this Gridfinity system. So what if I made the world's first Gridfinity optical comparator?
Got my optical comparator, making it Gridfinity for fun. Some say it ain't the best way, but it makes me laugh and it gets the job done. People talk about the machinist, say I'm doing it all wrong, but I'm happy with my setup, and at least I don't live in my parents' basement. Gridfinity, oh Gridfinity, making my workspace shine, keeping me organized, and now with measurements so fine. Oh! Now my tools are in their places, no more searching high and...
So the part is done and looking pretty decent. Yes, I am aware that I had stupidly long stickouts from the vise, but the part looks good, so I don't care. It does fit the Gridfinity bin. There's more wiggle than I would like. And I'm not sure yet if it is sitting on this bottom surface, like the bottom of the bin is sitting on this surface, or if these tapers just needed to be tighter in. I want it to be fairly self-locating on the taper. So it's too late to make these tapers smaller, but I can try moving the floor down to see if that does anything. Revised design, let's go. It has to do a tool change first.
My tools are in their places, no more searching high and low. Got compartments for the basics and the fancy stuff to show. Some might call it overkill, but I don't mind at all, 'cause when it comes to measuring, I'm having a ball.
Let's give it a shot. Oh yeah, that's perfect. So now it's resting on that taper and it can wiggle, but once you put force on it, it locks in. I think it just wiggles because it's so light. But if I make these out of aluminum, I think that'll be pretty good. If it wasn't clear earlier, I don't actually think this is a good way of mounting things, but the biggest forces on the part when they are on here is the force of acceleration when I turn this knob. It also has zero need to be repeatable and only needs to be like pretty close in terms of alignment. This part actually looks surprisingly good. My spindle bearings are dying, so I'm having a hard time getting good finishes, but these are reasonable. Time for op 2. I'm gonna try to be lazy and use this same vise, though I'll put in some parallels and grab it on the flats instead of the serrated.
They crumble, but my spirit won't crumble. In my workshop I'll hustle till I make perfection humble. Got this shiny new comparator with a lens that's crystal clear. Every detail magnified, no mistake can interfere. They said I went too fancy, spent more than I should, but this grid fit it all wrong. But I'm happy with my should. Gridfinity, Gridfinity, making my workspace shine.
Frick. So it might have been like 4 weeks since I last recorded a segment of this video, but we're back now. I think the last thing that happened in the video was I broke a tool because I paused the machine to get my camera. That's what I did. I paused the machine to get my camera out of it so that it could finish the cut. And I hit feed hold, took the part out, and when I hit cycle start again, it was already in the cut. That was my mistake. And because the tool takes time to accelerate back up to cutting speed, but the machine does not take very long to accelerate to cutting feed, the tool broke. So that's what happened there. But our part came out super, super well. This is our little Gridfinity base plate for the optical comparator, and I love it. It fits right on there, just like I was hoping for. If I want to screw it down with these screw holes, I will need to make some T-nuts for here, but upon further review, I think it's actually better to leave it loose because there's not a lot of wobble to it. However, I'm not always going to want to use this somewhat silly invention, and by not screwing it down, I can always just take it off and have the table available for normal use. So I think this will live just like that. I did do a very small amount of iteration on the work holding for this thing. I 3D printed some of these Gridfinity boxes. And honestly, the 3D printed ones would probably work just fine, but I am gonna make some out of metal here in a second. The biggest lesson learned was how tall to make these little fixtures. This one right here is as short as it can practically be. And in fact, I would say it's probably about 1 millimeter or two too short, depending on your part. If you look at the screen here, it doesn't show up very well on camera, but you can see that this M3 screw doesn't quite make it to the middle of the screen, so an extra millimeter or two would be nice. While the 3D printed ones really would be fine, and I'll probably still be 3D printing some in the future for like some sort of niche part holding, I did want to make some out of aluminum. And I had this bar of aluminum, but upon realizing that I needed them to be a little bit thicker than I was originally anticipating, I've discovered that that bar of aluminum won't work. So instead, we're going to be making them out of this is a block of A36 steel. It's a fairly vanilla mild steel, and I just happen to have several very big, very heavy chunks. I've had those sitting around for several months, and I just kind of want them gone, so I will be making the little fixtures out of that A36 steel. I would have preferred to have my base plate harder than the fixtures that go on top of it, but I don't know, it is what it is. I can always make a new base plate if it wears out, and if I wear the base plate of an optical comparator out, then like, I'm the problem, not my material choice. It's wild how projects can snowball on you. If you look at this stock here, you can see the worst saw cut of all time. Well, that cut resulted in me spending about 2 hours tuning up my bandsaw just so I could cut the material. It needed it, it's needed it for a long time, but I didn't exactly expect this project to take that long.
Shiny new comparator with the lenses crystal clear. Every detail magnified, no mistake can interfere. They said I went too fancy, spent more than I should, but this could fit all along. But I'm happy with my shirt. Gridfinity says I may crumble, but my spirit won't crumble. In my workshop I'll hustle, till I make perfection humble.
Probably should have gotten more machining footage, but it's the next day now, and I have 6 of these machined. Sort of. That first one, remember the one with the bad saw cut? That one does have some gouges. I think it'll be fine, but it is ugly. And then also, this deserves its own video, but I was experimenting with using my probe to update some wear offsets to be able to like automatically dial in parts. And the first one, I had it set up wrong, and so this one's like 10 thou undersized, but I don't think it'll actually make a difference. So at very least, I have 4 that I know are good, and I have 2 that may be usable. And if we stick this on the aluminum base, it actually works super well. There is very little wiggle. In fact, it's much more stable compared to the 3D printed ones. And I'm now feeling a lot more confident about this idea. The only wiggle is the wiggle between the bar on the bottom of this one and the side walls of this T-slot, because I didn't make it perfectly tight. I gave it some allowance. So our only wiggle is our allowance there. So now that I have all of my Op1s blanked out, we can move on to the Op2s, where these things actually become useful and differentiated. All of these blanks are identical because the bottom of the Gridfinity cubes are standardized. Now we need to do Op2, which is where the differentiation happens. So now you might be wondering how I'm gonna locate this part to be exactly on center for the second operation. And the answer to that is I don't need to. It doesn't need to be dead on because I have my probe. Now it'd be nice if I could probe in and hit this finished wall here before I start machining, but obviously you need like a really big probe tip to be able to get over that hat. So instead what I'm gonna do is machine off this hat here, And then in my program, it's gonna come in and probe the sides of the part to re-find that center. And as long as I have it here eyeballed within like 40 thou, it should find the center of the part every time. This is a really handy workflow when you're doing small batch production. Obviously, if you're doing a higher quantity, you're just gonna wanna put something with a work stop in there because the work stop doesn't take any cycle time, it just takes a little bit of setup time. This doesn't require any setup time, it only adds extra cycle time. My goal is to eliminate my time from as many of my processes as I can and push all the work onto the machine, because my goal is to say a one-person shop for as long as possible, and the more that the machine does, the less I can do, which means the more I can do. I think my deburr toolpath got a little bit too aggressive on me, but that looks fairly decent. This is what I was talking about with that deburr toolpath. You see this like X shape? That is the deburr toolpath trying to go in there with a ball mill and get rid of a burr, but really it just caused some like weird scalloping. Also right here, it tried to deburr that corner, which it just did not need to do at all. But the actual finishes of the floors are not bad. And it didn't break the tool, which I was honestly a little bit worried about. This was the blank that had those awful saw cuts, so this one is a little bit sacrificial. But I think this one is actually still usable. I'm gonna go ahead and make another one with this exact same pattern and a good blank, and I'm just going to fix that deburring issue. And then that way we can have two that we can put side by side and stretch parts across. The first two blocks are now done, and we can put them on here to do some testing, and they seem to work pretty well. The V's line up going across really nicely, and that lets me put them in a number of configurations for whatever makes sense for whatever the part I'm doing is. I have it set up so there is a ton of different grooves in different places, so depending on the part, I can always find something that I can get in focus, and I can rotate them to give me some different options. So I think this configuration here is what I will use the most. That puts the part fairly close to the front, which seems to be where this thing with this lens likes to focus. So you can see I can get it in focus there. I think this proves my concept pretty well, and now I can go on to machining the rest of them. Next up on the list is the one that I think will probably be the most useful. This gives me two different ledges at two different distances with just a simple rail in the back. So depending on the size of my part, I can either have it close to the lens or farther away from the lens, with the rail providing a nice square datum that I can use to make sure everything is lined up nicely. I just pulled the last part off the mill. Let's go take a look at what we've got. So in the end, I settled on 3 different designs. I actually had a 4th one designed, but I decided I would rather keep things in pairs instead of having one of 2 different things, and I only had 6 blanks. My last 2 designs are these more traditional rails. These will let me take apart and use the rails to align it just so that it is perpendicular to the light. This one has just one rail all the way in the back. This part here gives me 2 different rail options, with there being one very shallow rail on one side and one relatively deep rail on the other side. And again, I can rotate this 180 degrees, and I should be able to find some focal position somewhere here. And remember, the part can either be in front or behind the rail. I also can turn this 90 degrees and use that wall, the side wall here, to align a part. And as a bonus, I designed all of these different rail pieces to be at the same height. So if I had a big part, I could put like 3 of these in a row here. And that would let me stand on top of all 3. Depending on how I rotate them, it'll even give me a corner that I can use to align the parts. So let's say I'm inspecting 10 parts, I can make up a corner like this and just slide them in, check what I need to check, slide them out, put a new one on. I'm gonna store all of these little blocks in a Gridfinity grid that I have here sitting next to the machine. I'm sure as I go, I will 3D print or machine more of them for specific applications. And having them Gridfinity means I can just easily keep them organized there right next to the machine. I think the only thing left to do is to take some measurements. So I have a gauge block, I have a gauge pin, and I have a thread gauge here. I hope you all can see the screen there, but this is the best I can do. So for the gauge block, I'm going to use one of my rails. Put the gauge block up there, and I'm gonna hang it off the side of the rail just a little bit so I have a clean top and bottom. So let's make sure the whole part is in our travels. It should be. Let's get it focused. I should have cleaned it first. I think this would be a really good time to use something like Rodco putty, but I'm just gonna use a Kim wipe. All right, there we go. It's a little bit less fuzzy now. And now we have a focus. Okay. Let's go to the bottom of the part. And I'm going to set up my dial indicator here. I'm zeroing that out. And right about there. That is reading 1 inch and 1 thou. Let me try resetting our range, and we'll do that measurement again. Now we are reading 0.995, so 5/10 under. So we went from 1 thou over to 5/10 under. And in fact, if I just give it a little bit of a tweak to what may be a slightly better edge, I'm at exactly 1 inch. So it seems to be accurate. Our resolution isn't maybe perfect for measuring gauge blocks, but it is accurate. Let's try our gauge pin. Now switching to the V block. And it's gonna be a really similar measurement. I'm seeing dead nuts, 0.250. So that worked. All right, lastly, let's measure our thread here. My main camera was just not cooperating with this, but my cell phone seems to do pretty well. So let's do some measurements. First of all, we have this screw. And let's start by measuring the pitch. So I'm gonna move to the very bottom center of one of the little lands here. I guess it's a valley, one of the valleys. I think that's good. And I'm going to zero my dial indicator. And now let's move to the same point on the next one. It's kind of hard to do this for a phone, but right about there. All right, and if we check our gauge here, it gives us a 0.70, and this is in fact an M4 by 0.7, so that measurement is correct. Now let's figure out our minor diameter. I just zeroed my x-axis right there on this point, and I'm gonna go find a point on the other side that is basically the other valley here. I'm gonna find the tip of the other valley on the other side. And it should be right about there. Now this is reading 3.08. I'm not sure what the tolerance range for an M4 screw is supposed to be, but I'll put it on screen right here. Now we can check the major diameter in the same way. All right, and if we look at our gauge, it is 0.395. Again, I will flash the tolerance range on screen here, but this thread, I would guess, is in spec. So this piece of equipment maybe isn't going to revolutionize my shop, but it'll allow me to take some jobs that I couldn't take before because they had features that I wasn't able to measure. I can measure more things now. That means I can take more jobs, and that means I can choose better jobs, which means I can make more money. Thank you guys for watching. I'll see you in the next video.